Good day Bayaw! Welcome back to our channel Bayaw Tutorial. In this video, we are going to solve a problem that involves the overview of the heat transfer from thermodynamics and heat transfer. So here is our problem. A spherical ball with a surface temperature of 80 degrees Celsius is suspended in the middle air of a 300 degrees Celsius room. The emissivity of the ball surface is given to be 0.8 and the convection heat transfer coefficient is 25 watts per square meter degree Celsius. Find the total rate of heat transfer from the ball. So this is our illustration for this problem. So we have the spherical ball with a temperature of 80 degrees Celsius that is suspended in the middle of a 330 degrees Celsius room, and the diameter of ball is equals to 6 centimeter. So the given for this problem is the surface temperatures is equals to 80 degrees Celsius, the 30 degrees Celsius which is equal is the temperature for our room. The value for our diameter in centimeter is 6 and we converted it into meter which is equals to 0.06 meter. The emissivity is equals to 0.8 and the convection heat transfer coefficient is equals to 25 watts per square meter degree Celsius. So the solution, the heat transfer surface area is pi times d squared. So our diameter here is 0.6 meters squared. So by multiplying it into the pi, we can get the value of 0.0113097 meters squared. So under steady state conditions, the rates of convection and radiation heat transfer are equals to the H times the area times the change in temperature. So we have these values. 25 multiplied by 0.0113097 times the change in temperature 80 minus 30 degrees Celsius, and by simplifying this equation we can get the value for the rate of convection heat transfer which is equals to 14.137125 watts, and for our radiation heat transfer is equals to the emissivity times sigma times area times the change in the surface temperature and the T sub 0 raised to the power of 4. So by plugging the given values, we have the 0.8 times 0.011397 square meter times 5.67 times 10 raised to the power of negative 8 watts per square meter Kelvin multiplied by the 353 raised to the power of 4 minus 303 raised to the power of 4 Kelvin. So the equals to 3.64159 watts. Now we have the value for our convection and radiation heat transfer. We can now get the value for our total heat transfer rate. So the rate of the total heat transfer is equals to the difference of the rate of the convection heat transfer and the radiation heat transfer. So by plugging in the values, the value for the rate of the convection heat transfer which is equals to 14.137125 watts minus 3.6415 watts, and it is equals to 17.78 watts. So the total rate of heat transfer from the ball is equals to 17.78 watts. That's it.